Well, thank you guys for coming. Microphone, pick it up, I'm told. Thank you guys for coming. I'm Kevin Bong. That's right, we have to page down here. Our screen is a little messed up. It's going to screw me up all day. I'm Kevin Bong. I do IT hacking stuff. I also founded the mini Pwner Pentest Dropbox project. Yeah.
Hello, everybody. My name is Michael Vieau. I'm a pen tester as well with Sikich and 403 Labs. I do a lot of hardware hacking on the side, and Kevin was gracious enough to hand over the mini Pwner project to myself, so I'm currently the maintainer of that project.
A little bit about, we both work for 403 Labs. 403 Labs is a division of Sikich, which is a big accounting firm. We in 403 Labs do penetration testing, audits, all that fun stuff, like a lot of you guys here. If somebody's looking to get into that, we are hiring all the time, entry-level and experienced auditors, pen testers, whatever. So, shameless plug because they paid for us to be here. All right, so what are we talking about today? It's 5 hardware hacking projects, but yay, you actually get 6. So, bonus. Start a little bit about Frugal hardware hacking. So, Frugal hardware hacking, I think a barrier to entry for hardware hacking is I'm afraid I'm going to break stuff and it's hard and I don't want to spend money. That's definitely how I was, because I did screw up a lot and break a lot of things and that kind of stuff. But you can do it on the cheap. You got to be a little creative to do it on the cheap, but it's not that hard. Basic tools. If you can afford and want good tools, definitely get good tools. Get a Fluke multimeter. If you're trying to do it on the cheap, and if expensive tools are holding you back, the cheap tools work pretty good too. How many people are familiar with Harbor Freight tools? Like, it's awesome. $6 for the multimeter, and if you get the coupon from their flyer, it's like $3 or something like that. And they're nice too because I do a lot of stupid things like not having the right setting on my multimeter before I'm testing 120 volts, so I melt a multimeter every once in a while. So it's nice to get the cheap multimeters, wire cutters. It's nice to get a nice soldering iron, but again, a cheap one works too. So that's one of the big places to kind of start your frugal hardware hacking. And then the other, I buy a lot of cheap junk from overseas. 2 good places to do that. Well, it's not junk. Cheap, awesome stuff from overseas. Literally, you buy some of this stuff, so here's a Arduino Nano, $1.82. I can't think of any place I could get it shipped in the States for $1.82. It's $1.82 with free shipping from China. So the 2 good places, eBay. I don't know if you've been on AliExpress. It's like the Chinese version of Amazon, but it's just insane what you can buy there. So get Arduinos. A logic analyzer, we'll demo one of those, a knockoff of the Sela. If you were in the router hacking talk, he talked about the Sela logic analyzer. This is just a cheap knockoff of that. A TTL adapter is a nice thing to have. It's just kind of a serial adapter for talking to routers and things like that. But then buy other stuff to help you out. You can get bundles of jumper wires for 99 cents. Resistors and capacitors. This is crazy. So this is $5 here for 1,000 capacitors, like 50 little individual Ziploc bags. Someone has handwritten on every bag what the value of the capacitor is, and it's like $5. Like, again, what are they paying these people? I don't know. I feel bad buying it, but hopefully they're getting paid for it, so it's better than nothing. And proto boards as well. So yeah, I buy stuff that I think I'm going to want to use a month from now because it takes a little while to ship it from China, but it's kind of fun to get stuff in the mail from China all the time too. Every couple of days, like, oh, something new, some new toy to play with. So that's just, you can do it frugally. It's not that bad. And so all the projects we're going to talk about today are under that realm. It's like, let's find something inexpensive and let's hack it and see what we can do with it. And if it screws up or if it doesn't work, we're not out that much money and we learned something. So the first one, the RFID badge snooper, I did a talk similar to this, just this project a couple years ago here at Derbycon, but this is a little bit advanced to that because I figured out since then how to get it to do the Proxmark, the HID cards. If you're not familiar with the HID cards, they look like these, the Proxcard 2s or whatever. Really common proximity card badge swipe type system. Works on 125 kilohertz. And you can buy a Proxmark, what are they, $300 or something like that, that'll sniff the card and play back the card. So we're going to show how you can do that much more cheaply. And the first half of that is sniffing the card, snooping the card. we're going to go fast. I've got a lot of slides. We're going to have these slides on the minipwner.com website. We'll have that up here too. So don't feel like I'm going too fast because I have to. So we're going to take a cheap RFID lock like this. And that one's built for like, it's not built for the HID cards. It's built for these little tokens. They're EM400. It's a simpler protocol. But it turns out that the circuitry they build into those decodes the signal in a way that you can get the HID card, read a HID card with it as well. Michael can pass that around. And the way we're going to do that is we're just going to find a couple certain, well, I'm getting ahead of myself. So to do this project, you need one of these locks. It was $10 2 years ago. It's probably even cheaper now. You need an Arduino Nano. There it was $350 2 years ago because it's an older slide, but you saw $1.82 from China. The logic analyzers, I know they're cheaper than that now too. It's insane. So those are what you need, a couple jumper wires. And there is some soldering on this one because you do need to connect to the board. And you need a DC adapter to power that lock that's getting passed around. And the biggest kind of most challenging thing with this project is to find that demodulated signal. So there's a pin on that, there's a signal on that board somewhere that's coming from the antenna, got partially decoded, and is going to the chip. There's a chip on there that's processing it. Well, you would just want to tap into that signal and read it with your Arduino as well. A couple ways to find it. The other weird thing is those boards for these locks, every time I order them, I get a different design. Apparently it's cheaper to redesign the board because they can get cheaper components. So I've gotten like 5 different versions of it every time I order a small batch of them. So the ones I have out on the minipwner.com website, there'll be pictures showing where I found, the signal pin on this one was the 4th one down on the bottom of the board, and there was a place to do a ground. Here's another version where they actually had a list of headers and, an RFID signal there. And this is cool too, because this project, you're not only doing the RFID, like there's a memory chip there that holds the key codes for badges that are in there. And so you can actually use these other pins here to read and write that memory chip or intercept those signals. So it's a really cool, like, cheap hacking platform to just play with locks as well. But this is where a logic analyzer can come in handy. I'm going to show you real quick. So I've hooked this logic analyzer up to the board. Not close enough. I can do it with one. I can use my computer one-handed. So this is that logic analyzer. It's hooked up to that pin that I was talking about. We had to find the right pin. And we actually use that logic analyzer one way to find it. You'll find different areas have different signals. And if I look at this pin, it looks like it's just got a standing square wave, and we actually see it's 125 kilohertz square wave, which is, we know it's 125 kilohertz protocol. So we think we're close. If I throw this HID prox card on it, and do the same capture and don't jiggle around things, it looks about the same, but I'm actually zooming in. It's not 125 kilohertz anymore. And it's not an even square wave anymore. If you look really close, it's like compressed and stretched and compressed and stretched. That's one of the modulations that this HID card uses. It's frequency shift keying. And so like a compressed set of waves is a 0 and an expanded is 1, or it might be the opposite. So we're actually seeing the signal that's the number on this card. This card's not smart. It's dumb. Anytime it gets into an 125 kilohertz RFID field, it just starts spitting out its number using this modulation. So the first step, and you don't really need to do this step, it's kind of a fun one to do, get the logic analyzer, spend a few bucks and just, play with it. But you don't need it to build the project here, because the next step is we found that signal. Now we're just going to hook an Arduino onto it instead. And the Arduino has some nifty features like interrupts and timers. So we can actually use those features and build basically a stopwatch that's measuring the length of each of those different signals. So if I'm going to start it when the signal goes high, stop it when the signal goes low, and find the microseconds for that, and measure that, and do some fun math, and you end up getting a card number. So I've got the I will have, on the drive home, I'm going to be posting this stuff out here, if it's not there already. But I'll show you it in action. So here's just the, come on. Oh, I've got the reader card on there, so it's already doing it. So, so this card says it's number 246. There were some cheap ones. So usually the number's longer. So if I put it on there, it's going to start to say, yeah, I'm seeing card number 246. This one says 271, saying card number 271. So the binary you see there is the actual signal that the card is sending out, and then the 271 is the math to decode it. So yeah, for $10, well, $12 if you go $10 for the card reader, and another $2 for the Nano, you've got half of a Proxmark, which is read a HID card if you can get it close enough to the reader. So that is the first project. Yeah, question. Have I worked on shrinking it down from the full lock size? So I hesitate to say it. I have this awesome idea, and I'm so freaking close. So these badge readers, like it has to power the card and get the signal and all that. But if you put another small coil next to this reader, and then put your card between it, that coil will get the same signal as the big coil in the card reader, but it's much weaker. But it's the exact same signal, and I'm positive you could build a device that's probably about this big that you could stick onto the side of one of these HID card readers and just have it kind of vampire tap off those signals when people are reading them. I just haven't been able to build a clean enough circuit to catch it because the signal's so weak. So if anybody is awesome about that, but yeah, you could shrink it down that way. But for this part of it, like being able to bring a card near it and read it, you kind of need the big antenna because you need to have a big enough RF field to power this card for it to modulate the signal. Any other questions on that first project? Could you take a HID reader outside an option? Yeah. Yeah. So one of the things I actually have one. So this was my black version, which was hide the Arduino and some batteries and stuff inside of it and have it just log it and stick it next to the existing one. Because people going in big office buildings, usually there's 2 or 3 of these anyway. Like, you know, maybe they'll scan their badge on mine. So. All right. So that's the snooper. So that gets us the number off the card. Now what do we do with it? So the spoofer is kind of cool too. We're going to build one of these. And you don't need too many components for it. You need an antenna, and what we're actually using the antenna is an existing key that came, when you buy these locks, I don't know if you saw, it came with 10 keys. You know, for $10 you get the lock and 10 keys. Well, you can use one of the keys as the antenna for this project. And it's only 3 components as well as the Arduino to build the spoofer part, and I'll show you why that is. So I've manufactured a few PCBs. If you go to the Mini Pwner website, we'll have the templates so you could etch your own or manufacture your own. But it's only 3 components. You know, you can do it on protoboard. You can solder it together however works for you, or even do it in a solderless breadboard, something like that. So the first step is to turn the key fob into the antenna. The key fob has the coil, the antenna that we want, but it also has its own circuitry inside of it already that it's going to give its own signal. So we just need to destroy that circuitry. I found it works best to kind of drill through it with a little drill, or maybe cut it with a knife. But you just need to break that little black blob there is the circuitry. Just break that and it stops working. The other thing is it's really hard to solder onto those really fine wires. So you're much better soldering onto the 2 little solder points there that their circuitry's on. So once you cut their circuitry, you've got some nice solder points for yourself too. But yeah, don't try and remove the antenna. It's glued in. The wires are so fine, you just wreck everything. So there's a picture of me having glued it or drilled through it. And then, you know, you kind of see once I've glued the leads onto it. And if you've done it right, you can use your multi-tester and just test the resistance, the continuity through that coil. And it won't be 0 because there's so much wire there. You get about 100 or 200 ohms. That means you did it right. And there's me doing that. Like I said, the circuit is really simple. The way the circuit works is that D9 on the Arduino, the data pin, is giving that signal that you saw, kind of it needs to turn on or turn off to give the 1010 signal. And this little circuit over here with the capacitor and the inductor, well, if you put a capacitor and inductor is just a coil of wire, you put the two of those together, you get a circuit that resonates. And we're choosing a capacitor that works with one of these keys to make it resonate at 125 kilohertz. So if you put this just capacitor inductor circuit into one of the fields, like one of these badges make, the 125 kilohertz field, it's going to start oscillating at 125 kilohertz and kind of help build up that field. Well, now if we start close that circuit with this transistor just acting as a switch, you're damping that field. So you basically got a circuit oscillating here at 125 kilohertz, and you're turning it on and off to damp it or not damp it. And in the end, you end up with doing the same exact thing as the card is doing. So to build this, you solder that circuit together. You can get the code. Code is really simple from, again, minipwner.com. And the demo for this, I'm just going to show this video. So this is looks as simple as that. So yeah, we'll pass that around too if you want to start that around, Michael. So that's project 2. We're moving quickly, but that's okay. I've got more demos coming up. Any questions on the spoofer? If you had a rewritable, do they make rewritable RFID? Oh, then you probably could. Yeah, I would think so. If you have a rewritable one. I haven't worked with a rewritable one before. Yeah. What kind of writer do you need then?
I use the reference Proxmark.
Oh, okay. Okay. So it sounds like you can buy rewritable tags and use like a Proxmark to write to it. I'll have to maybe see if I can get this device to write to it, if I get those. The next one, I'm going to turn it over to my friend Michael here, who's going to talk about pen testing drop boxes.
So the pen testing Dropbox, the one we're primarily talking about today is the Mini Pwner, which Kevin came up with originally in 2012. So the version 1 was actually based off of this little guy, which is the TP-Link 703N. It looks exactly like this 702, but it's not. You have to get the 703N from China. If you get the 702, it does not work. I came with a 4 gig memory card, and the one disadvantage with this is you did need an external battery for it. It's an awesome little device, obviously very small, compact, but it takes a couple of different things to put it together to make it into a Dropbox. So last year we got together and started thinking about how can we make this better, right? How can we make it more convenient? So what we decided to start using was the 3040. Which is one of these guys. Right, so I'm sure you're all familiar with the TP-Link 3040. It's very popular these days. Comes with an internal battery, internal wireless, same USB, and then an Ethernet port as well. Has some other advantages that I'll talk about in a little bit with the toggle switch, but you can build your own. The code is out there on minipwner.com if you want to use it. I'm trying to make it a little bit easier as well, but for right now, there's just build instructions. So if you follow the instructions, I've had good feedback. They say they work. So you obviously need one of these. Get any kind of USB drive or any kind of USB drive you want. I like the 16 gig Cruiser Fits because they're nice and small. They don't get hung up on anything. Right now, still using Barrier Breaker. Haven't tried Chaos Commer. So I have to look at the code, make sure it's still going to work. But Barrier Breaker, install that. There's a Mini Pwner overlay package that you can download. It's just a tar file. So put that on your Mini Pwner, extract it. There's a setup script, and it basically builds the Mini Pwner for you. So pretty straightforward. And then you can install any packages you want. Oh, these are just the notes from the website itself. So that's what you have to do on the Mini Pwner. You have to actually set up the USB capability in the TP-Link 3040 first. There is a trick to modifying the FS tab. So this is what your FS tab, you want this to look like for the first time. So your target is the overlay. Your device is SDA2. and then you have some different options up top there. So you do that once, then you have to do the pivot route. You guys all familiar with that? It's a pretty straightforward process. Those are the commands that you use. You have to edit etc config ftab again, and there's a couple things you want to change. Your target now should be / and put a delay in your put a delay option in there. Now when it boots up, it'll be booting off of, it'll boot up, but then it'll read the OpenWrt operating system off the USB drive. So now you'll have that 16 gig. So that's the magic trick to that. And of course, you can install any packages you want. I've got a list of recommended packages that we like to use out on the site. Like I said before, applying the overlay is very straightforward. Just run the setup script. Oh, and like I was saying, okay, so the 3-position switch on the side, we came up with this little thing called mini modes. And what a mini mode allows you to do is you can control it through the 3-position switch. So the middle position is always set up, but then you have the ability to predefine. So if you wanted to set it up for war walking with Kismet, if you wanted to set it up for rogue access point, if you wanted to turn on, I don't know, TCP dump with some certain flags, or start an Nmap scan, or do whatever you could think of. What you can do is, if you take a look at the site, there's just a file structure on one of these, right? It's just Linux. So under /minipwner mini modes, you can actually build out files, build out your folder structure, and when it boots up, it'll read that, and that'll become a mini mode. You put bash scripts, Perl scripts, or Python scripts in there, it will execute that code. So as you flip the switch, it'll execute that code for you. So walking into a pen test, I can now have this set up to do 2 things right off the bat. And if, gosh, I get there and there's something else I didn't think of, right? It would be really great if I had a war walking device. I could go in through the web interface, my wonderful HTML skills here. You can go into the web interface and use the drop downs, grab a new mini mode, and then instantly flip the switch, and it's at that new settings. So very easy. That was kind of the goal, because I'm extremely lazy. So I like to automate as much as humanly possible. And moving forward, started making what we're calling the Black Edition. It's based off of the 3040 as well. That's one of these guys right here. So it's still a 3040, but what we've done is taken out the LED, the power LED. Hard to see, but it used to be right there. Basically just broke that. So there's no longer a power LED on it, so it won't flash. Added the correct antenna, and gave direct serial access, so you don't actually have to open it up. I've done that for you. And of course, wrapped it in very stylish matte black vinyl, because who doesn't love matte black vinyl? What's that? Not the 80s. No, the 80s did not. But
it's pretty cool that the 3040 is kind of pretty easy to actually hack with some of those. The 3040 is pretty easy to actually hack with some of those changes. You can see, Michael, here, there's a 4-pin header there for the serial interface, so you don't have to go find pads or whatever. There's actually pinholes for it. And while there's not a good connector for the antenna connector, it's a matter of knocking off a resistor and soldering the antenna onto the point where the resistor was. So that's a hardware hack that you can do to yours as well.
Yeah, absolutely. And I can't take full credit for all this. Actually, somebody on the Minipwner forums originally posted this. I don't remember his name off the top of my head, but he gave me the original idea to do the antenna mod. It is very difficult. Obviously, it's very small in there. You'll notice there's a little black piece of tape. So what I do is I knock off the resistor and I put a piece of black tape over the other end, because otherwise I end up soldering to both. Doesn't like that very much. So that is the Minipwner Black. Also comes with the 3 dB antenna, obviously, because you kind of need one. So we are working on a new interface, trying to go with more of a web-based thing. It's not going to be full functionality. That's not the goal. Obviously, I'm a big believer in the command line. I like to type things, but it's hard to do from your phone. Right? If you're dropping this box off, you want to have some ability to get into the box and do something with it while you're on site. So the goal is really just to build a web interface that you can point and click and pull down some mini modes or change some settings or start an Nmap scan and do some basic functionality things. So if you guys have any ideas, that's what I'd love to hear from you on. I've created another package of mini modes that hopefully will be coming out soon. I was really hoping to have it done for this weekend, but that just wasn't going to happen. On the forums, if you look on the forums, there's actually a new thread that I've started for future ideas. So I'm trying to gather ideas for anything you guys would like to see it do in the future. We'll certainly take those and see what we can do with those. So if there's functionality that you want, I know Karma's a big one. I get asked about that quite a bit. But if there's other things that we want to do, let us know.
Two questions. First, instead of putting an infrared LED so that you can look at it through phone camera, and the second is, do you have a GitHub that distributes the web-based live? We're good at that?
Good question. So the questions were about an IR, adding an IR LED to it. We certainly could look at that. No, I'd never given that any thought. Yeah, one of the problems is it is a flush mount LED, so it is pretty difficult to solder in there. I'm not the world's best solderer, but certainly could give it a shot. That's a good idea.
And also a lot of these, I don't know about the 3040, but many of them have extra GPIO pins that are unused that you could find a pad to solder to, so you could potentially, hook up. So I think the power LED, I don't know if it's controlled by the CPU or if it just goes on when the power's on.
No, it's just on when
yeah,
the power's on. That's the problem.
But there's other pads. But there's other pads that actually are GPIO, and you can actually manipulate those.
While we're talking about LEDs, that's what I wanted to mention. So the reason I broke the power LED is because you can't control through GPIO. It's just on when the power's on, and there's no if and buts about it. But the other 3 LEDs that are on there, you can actually control through GPIO settings. So I can make it go completely dark, put it in a corner, and you're not going to see it, right? Or also, we like to use the LEDs for finding stuff, right? So LED is on. We go around and start plugging it into different ports. When it gets a connection, the LED turns off. So you can use that as a little feedback indicator. So we also have 3 LEDs to kind of play with, right? And you had a second question about the web interface. It's not on a GitHub right now. I'm actually not the one developing it because clearly I do not have the skills to HTML anything. So it's actually going to be based off of Sword. If you guys have ever seen that interface, I'm working with a developer of Sword right now, and he's actually creating us a new interface, which we're prototyping it out right now. He should be launching it on his site next week, I think he said. So stay tuned to that. But yeah, I've thought about putting the code up on GitHub and kind of making it more official, because right now it's me. So and I really do. I want help. I want people from the community to chime in, and tell me what you guys want.
Other questions?
Yes, sir. Yeah, it's a good question. Bluetooth to serial adapters. No, I haven't had the time to do one of those yet. There's no room in the box, so it would have to be an add-on. To like maybe tape one on to the casing. But that's certainly something. That's a good idea.
Yeah. One of the challenges you come in is it's only got one USB port. So you got to kind of choose, do I want a USB thumb drive there? Do I want a Bluetooth port? Do I want a hub? And it gets messy.
I think it's just power.
Yeah, it's just power, but you could probably do some creative hacking to get something to happen. Very small parts inside there, though.
Yeah, I think that's probably one of the downfalls with the 3040. The 703 was nice to work with. It's kind of a square box, and the board's thin, so you have a little airspace in there to solder on other wires and do some things. The 3040, if you're certainly welcome to take a look at this, but the serial port, there's so little space. I actually have to mill out a slot on the cover to get the jumpers in there. So it's very, very tight inside. Questions, comments? All right. We'll turn it back over to the Mr. Bong show.
So next up, helical Wi-Fi antenna. So how many people have tried building a Cantenna before or a Yagi before? So I did those things. I'm like, oh, a Cantenna, I'm going to build one. And I built one, and it didn't work for crap. And then I found a design for, like, build your own Yagi. And it was, you know, a little tedious because it's very exacting measurements and this and that. And I built it, didn't work for crap. Then I came across this, and it was really cool. So I thought I'd share it. So this is just a number of different pictures of helical antennas. So a helical antenna, the orientation of the signal is actually, I'm going to say this wrong because I completely forgot, but it's not vertical or horizontal like a linear antenna, but actually most signals aren't truly linear or circular. They're just some variation of both. So these work pretty well, even for that. And you can build them for a variety of different frequencies. Like the one we're building here is for 2.4 gigahertz, but we'll see a calculator where you can build one for 5 gigahertz if you want to do 802.11a or n or something like that. But it's nice because I built it and it actually worked. So apparently I did something right compared to those other two. And it wasn't that hard or expensive to build either. So let's take a look at that. So the first one I built was this wooden version one. I just, the key things with we'll get to it, is just the spacing of the coil. So the wooden one was nice because I had woodworking tools to actually cut grooves, so all that fell into the right place. But I thought, well, here for the con, not everybody's going to have, you know, a radial arm saw that they can do this kind of stuff, so let's find an easier way. But that was the first one. The second one here, we'll pass it around. Is what I came up with kind of for the con here. It's a very flexible platform because you really only need a few parts. Did I skip that already? I didn't skip that yet. You basically need before we send that around, let me just show the parts on it. Sorry, flake. So you need a reflector, and the width of the reflector needs to be basically as big as the wavelength of what you're doing. So this is 2.4 gigahertz, which means the wavelength is about 4.8 inches. This plate is actually just a tiny bit shorter than that, so I'm probably losing a little signal for any, you know, for certain waves that are coming at me, but I wasn't going to worry too much about it. You can find pretty much any flat metal reflector to be your reflector. And then you need some way to have this coil be spaced appropriately and have an internal diameter of just over 1.5 inches. And we'll see how we get to that.
Wasn't this not quite the right diameter?
That might be, that tube is a little bit too small, but not really enough too small to worry about. Yeah, it's a sink drain pipe. I think we'll. So here, we'll get to the parts we need. You need 14 gauge wire, which isn't too hard to find. Here's 18 cents a foot at Home Depot. You need a tube to wrap it around that's 1.5 inch OD. Unfortunately, none of the PVC you'll get in the store is 1.5 inch OD, but this tailpiece for your bathroom sink or whatever is exactly 1.5 inch OD. So that works out well. It's like $2 for that. We need a flat metal disc for the bottom. And I just shopped around like I was at Walmart, and hey, I could have gotten hot cocoa and used the bottom of that can. Here at Home Depot, they had some, I think that was aluminum flashing that was like 5 by 8 inch, which would have been perfect. I liked this metal plate that was in the electrical aisle, because it was very rigid. And another thing you're going to need is just a tiny little piece of likely copper metal strip because it's easier to solder. We'll talk about why we need that. It's for impedance matching. All right, so how do we build that thing that's coming around? Well, the first thing is got to figure out how we're going to connect the tube to that reflector. I've done it with hot glue. I saw somebody had a good idea of connecting it with zip ties, and that's how this one that's going around goes on because they're just plastic and they're kind of nice and you can disconnect them. And they hold it really rigidly. So it's hard to see, but I've got holes in the plate there and then holes in the tube that line up, and I'll just put the zip ties through that and connect it on. And then you have to mark the tube for that coil. I kind of skipped how you get to that. There's calculators out there on the internet where you say, okay, I want a 2.4 gigahertz antenna. In this case, I said I'm going to use inches as my units, 2425 megahertz or 2.4 gigahertz. So it's telling me my wavelength is 4.87 inches, the diameter of the tube I need to use, and that's where I said, so we see the diameter the diameter of the coil needs to be 1.61 inches. So I'm thinking if I wrap a 14 gauge wire on the outside of a 1.5 inch tube, I've got to be pretty close to 1.6 inches of the diameter of that coil itself. You know, how many turns? So if you end up with a longer antenna with more turns, you get less efficiency, but you get a narrower bandwidth. You know, kind of the 5 to 9 is probably a good range for the length and all that kind of stuff. Yeah. So that's how you figure it. You could put 5 gigahertz in there and you'd end up with a smaller antenna, but it would work for 5 gigahertz. Please interrupt me if you have questions, because I don't think to look up as often as I should. So we marked the tube here. I spaced it out 1 3/16 inches, and then I actually went to the other side of the tube and made the same spacing, but offset by half of that, so that I could figure out how the wire needs to go around the tube. And then, you know, the next trick is to find a dowel or something round, like a broom handle that's a bit smaller than the tube, and just wrap your coil tightly around it, because you'll get a nice shape that way. It's kind of tight, and then I can take that coil of wire and actually wrap it around my tube. Here you can see the first step that I did was to wrap it around and just, you know, roughly tape it as close as I can to those marks. The coil was, you know, had a little tension to it, so it was pulling itself out of place. But it got it close enough that I got it lined up pretty well. Where the next step then was to just take the electrical tape and hold the wire right over those marks, and as I'm holding the wire right over those marks, tape it down. And that's what you see coming around now. So it's actually pretty simple, and I think it turned out pretty well. There's other options as well. Like I said, you could cut out wood or other materials with grooves to actually get the wire to fall into the right place. This seemed like a nice approach to someone who doesn't really need any power tools other than maybe something to drill the plate if that's how you're connecting the plate on. So that's how we wrap the coil around the tube. So the antenna mount. So this is one of the challenging parts that's not as easy to find at Walmart. You got two options. You can buy a pigtail lead. What you need is an RPSMA. It's the same thing as your standard antenna has. So you can order them online on Amazon or from China or something. I've built a couple of these antennas where all I've done is taken a standard whip antenna. Geez, I've got so many routers here. I should have one handy. So I wouldn't take one of these because this is Michael's baby router. He loves this router. But if you look inside of these, you'll see there's actually a little bit of cable in there before it gets up to the antenna. So I've torn these antennas apart and used them as my connector. Because I didn't want to wait for ordering a pigtail. So you could do that. Just tear apart an antenna you've got. Like how many of us already have a couple of routers sitting in a box down in the basement because we upgraded and just threw it in a box. But so that antenna connector, you got two connections. The shield or the ground of it needs to connect to the reflector, and then that central pin, the signal pin, needs to connect to the bottom of the antenna coil. I think I've got a better picture of that coming up here. But before we get to that, we have to think about impedance matching. So what is impedance matching? I'm not an RF engineer, and this is really confusing for me. But basically, my understanding of it is if you've got an alternating current going through a circuit, it's going to have impedance, which is kind of a combination of the resistance of anything that's like a resistor in the circuit, as well as the reactance, which is the opposition to an alternating current of certain devices and things like that, capacitors and whatever. And so to be able to transfer power from one circuit to the next that's an alternating current, you need to match the impedance of both sides. I don't know the magic where people come up with this, but there's a guy who did this, like rcgroups.com. I should have a screenshot of that page, but I don't. But he actually spent a lot of time testing a number of different ways of doing impedance matching on helical antennas like this at 2.4 gigahertz and similar frequencies, because he was building them for tracking RC like drones and things like that. And so he came up with a couple of cool ways of doing it. The coolest and easiest one, he calls it a wave trap. And you're basically taking a strip of metal that's 1/8 of a wavelength wide by 1/16 of a wavelength long, which ends up being a 5/8 inch by 5/16 inch for our 2.4 gigahertz. Just cutting out a slip of metal that size and soldering it right after the point on the antenna. So here's the first step. I cut out that little chip of metal, just the right size, and then I put a little bead of solder just on an edge of it because I'm going to have to solder it to my copper wire. And then here's what it looks like when the whole thing is done. So it's got to be a certain distance from the antenna connection point, and then it's got to be soldered onto the wire. but you can see I've got it soldered to the antenna connection point. The shield of the antenna connector is connected to the reflector. I've got that wave trap on there, and based on the website I read, he said it works. It seems to, because this antenna actually works pretty well for me. But that's kind of the toughest part. One of the things that I thought would be cool would be to take one of these antennas and you know, I've done some of the you know, sitting in the city hall parking lot, like testing their Wi-Fi with like an antenna on the dashboard, knowing, oh boy, it sure looks suspicious. So I thought, wouldn't I look less suspicious if I just had a teddy bear on the laptop or walking around with just a teddy bear? So this has the antenna sticking out the foot and the reflectors here in the head. You know, I've got the connector in the back. Thought about putting a mini Pwner inside of it, and so it's all self-enclosed because we've got the antenna connectors on the mini Pwner. So I thought, yeah, that's not that suspicious. Though the first time I tried, you know, really used it, it still was kind of suspicious. Maybe even a little more suspicious. I don't know. So that's the Wi-Fi antenna. Any questions? I do not know the gain because I am not an RF engineer, and yeah. The calculator will tell you what it should be. I'm sure I did a sloppy job, so it doesn't match that. But one of the things is I understand this helical antenna design is a bit forgiving. It has a wide bandwidth, so if you don't got the coil just right, you know. And my experience is that, because like I said, I built a Antenna, it didn't work. I built a Yagi, it didn't work. I built this, and it's like, oh, that's cool. It works. Yeah, so we actually this was actually, we were testing for our last talk this morning about, like, we had a bank of routers inside the building, and we were testing like the ability to connect to them. And I definitely saw a stronger signal with the Bear than I did with just the whip antenna when we were out in the parking lot. It was only like the power level indicator on my Wi-Fi adapter was only, you know, maybe 5 to 10 more. It wasn't a substantial difference, but that's still a substantial difference because the power level indicator is pretty short range it actually works in.
And that's in comparison to the 5 dB whip antenna off of an L. So that's what we were testing next to it. Yep. The previous talk that you all saw and not, right?
Have I tried the antennas from Hobby King and stuff? The only antenna that I purchased and tried was a cheap aluminum Yagi antenna that's like a square bar with then like aluminum round tubes through it. And that thing, I think, works worse than a whip antenna.
Well, I know they're rapid.
Oh, okay, so yeah, I'd be interested if I went through the effort of getting some equipment that could measure gain. I'd love to like try some of my antennas against like commercial antennas and kind of do a bake off, because I think someone needs to do that, because I purchased an antenna thinking this is cool and it was a piece of crap. Other questions? Cool. This next one's going to be quick. It's a little inline sniffer. So the inspiration for this, how many are familiar with the NSA Playset? So a few. So the NSA Playset, some years ago with the Snowden leaks, one of the leaks was, hey, here's some old documentation from the NSA about different gear that the NSA uses that has fancy code names and does cool things. And I know it's top secret, so I didn't actually put any slides showing that actual leak here. But here's just a website that someone came up with, hey, let's build the NSA Playset, which is, let's get some community open source versions of each of these NSA tools that they've built. And so they had a list of what are all the ones you want to build. And one of them here that they listed was called Firewalk by the NSA. And it's cool when you build your own tool, you get to come up with your own name for it. That's as absurd as their tools. But so their Firewalk is a device that looks identical to a standard RJ45 socket, but allows data to be monitored or manipulated. And I thought, well, I can build something probably kind of like that. Yeah, we can. Yeah, go ahead and hand it around. Yeah. I built one of these and lost it at ThoughtCon somehow. So what are the parts for this? It's just two real important parts. We got this Next 3020 router, which is similar to the TP-Links. What's cool about the Next router, it's got two USB or two Ethernet interfaces. It's also a really cool router because it's got 8 mega flash versus a lot of TP-Links only have 4, so you've got a little more space for programs on it. But it's the same thing. You're still flashing it with OpenWrt like we talked about with the mini Pwner. So we've got our own Linux mini variant on there that we can manage with it. So basically a little router with Linux. And then this TP-Link thing here is a power over Ethernet splitter. So the theory is if you find a company that's running power over Ethernet, you could put this in the middle of a cable, and the power over Ethernet would power your router, and you'd still have an Ethernet jack for whatever computer's plugged into it.
Not very big. I don't think it would fit in the wall like our Kevin's first program.
Yeah, well, so I've got a picture of that. So this is that set hooked together, and I actually had it up and running and sniffing. It worked really well. You're not ending up passing the power of Ethernet through it, so if you know a PC is going to be connected to this, it works fine because PCs aren't power over Ethernet, but you couldn't put this behind an IP phone. But another variant I had put together, this is the one that I lost at ThoughtCon somehow, but so, found a standard socket, wall socket, the cover plate, and kind of put the wiring together where I've got up in the top, the red there is the guts of that next router, and on the bottom is just a little DC regulator that'll go from 47 volts is power everything. What? 48 volts power over Ethernet. Bring it down to 5 volts, which the router runs on. So if you know that they've got a PoE device down the line, you could use this to kind of tap into that and just drain a little power off of that. That router only runs like 100 milliamps, so you're not really pulling much juice with doing it. And this did fit in the whole thing. 5 minutes? Holy sh! Okay, so that's that. We're going to go really fast. Lots of places you could hide it. You can install network stuff on it. Yeah. So these will be out on the website. I want to get to the next thing, though. Really cool thing. So because you don't have a USB device in it, maybe, but you connect to it with your Wi-Fi, you can run TCP dump on it to capture the traffic going through the Ethernet ports, and then ship that out via the Wi-Fi to your laptop with Netcat. So there's a command to do that. So I can live capture, and it stores it on my laptop. It's not storing it locally on the router. And then the bonus one. We'll get to see it. It's really fast. So I talked about how a lot of the Arduino devices have that little FTDI chip. You can use it as a USB TTL adapter. No, we talked about that this morning. Never mind. But there's an Arduino board called the Leonardo, or the Arduino Micro, not the Mini, but the Micro. They're both based on this Atmega 32U chip, and that has a USB adapter built into it. They don't need a separate FTDI USB adapter. And that means you can make this device very easily a USB keyboard or mouse. What does that mean? Well, you could do a Teensy-style USB attack, if you're familiar with that, where you just plug it in to a device. The device thinks it's a keyboard, and you send keystrokes, like shell commands or something like that. Or I built a script to do like a mouse annoyatron, where you plug it in, and it pretends it's a mouse, and you can have two mice on a system, and it just moves the mouse cursor very slowly, kind of over a matter of seconds, in like a sine wave pattern or whatever. So if you're trying to use the mouse, it's like, why is my mouse drifting? But the other thing I thought about that when we were getting ready for this talk and my laptop kept locking was, wouldn't that be nice to just turn it into send a couple mouse strokes every 5 minutes so that my computer doesn't lock, because this has the corporate, yeah. So don't do that, Michael says, because it's security con. And the last thing you do with this with the Arduino Leonardo is, I don't know if you're familiar with the Makey Makey, but it's pretty cool. What the Makey Makey is, it looks like that. But it's a really simple circuit. Basically, all the Makey Makey is a very high level resistor. So this red circuit is what it normally looks like. You've got power, which is 5 volts on red, going through a very high resistor to a data pin. And as long as that's the only thing connected to it, it says, I'm positive. I'm a number 1 because I've got power going to that. But now if we put something with even slightly less resistance, like a banana, in that circuit between ground, now it says I'm grounded, I'm negative. So you just turn that switch off by touching a banana. And so they have a series of those. You know, my little module here has 5. The Makey Makey has 18 of them. But this is how you build your circuit for it. You download the Makey Makey code. I soldered it together on a proto board here. You can get this on the website, and I will just do the demo really quick, which is, we bring up this. So this is the Makey Makey piano. Hopefully it works when I plug it in. So now it's got a keyboard, and it's just taking keystrokes. Can I give this to you? And so I need to ground myself. That's the black wire. And then I could hook these to like a banana or something, and every time I touch one of the clips, it should play.
Why don't you give me some?
What's that? You're not touching ground, though.
Well, I understand that.
But yeah, so you can build something cool like that. The Makey is really cool. You can build one with Arduino Leonardo for cheap and fun.
That doesn't help, does it?
Yeah, so that's it. Sorry we ran out of time.